Let's start the meeting right away. I'm sorry to be late. This room was occupied by other folks, and that meeting went a little bit longer. So for today, I was thinking that we should go probably over the items that we had for 112 and see what is left for the next release and what is done. And then for the next release, for the next meeting, we are going to plan the next release items. What do you guys think, especially since Klaus and Wei and Harry are all here? I would like to hear your opinion. Does it make sense for the next meeting or meetings next couple of meetings to go over the items for 113 and plan for that? Does it make sense?
Yeah, it makes sense to me.
Okay.
Yeah, sounds good.
Okay, so for today, let's see what is done for 112 and what is left to be done. One of the items was equivalence cache. Actually, I went back and looked at the equivalence cache, and I saw that in the past 6 months, basically the past 2 releases, I have reviewed PRs and docs, a total of 10 PRs and documents for the equivalence cache. Mostly, I guess, PRs for making various changes to equivalence cache. And we are still at a position that we don't feel like equivalence cache is there. So it probably makes sense to have equivalence cache for, at the moment, I have only one predicate, which is interpod affinity. And that's the one that we have seen significant improvement. But even for that, we have had some new optimizations that has increased performance of affinity by another 10x or so. So even for that, we are probably not going to see as much improvement anymore. So the question is now, should we continue with the current equivalence cache, given that it adds quite a bit of complexity, especially with respect to invalidation and the race condition between invalidations and the regular workflow of the scheduler, basically snapshotting and running the predicates and everything. So the big question for us at the moment is whether it makes sense to keep equivalence cache. I would like to hear Harry's opinion, and then we can discuss with you folks if you have any ideas or what is your take on that. So let's start with Harry. Harry, what do you think?
Yeah, so actually the background we work out equivalent cache is pretty early, which at that time we don't have enough scheduler cache. That is why at that time equivalent cache works very well. But today we already have, I can see that we already have quite enough scheduler cache. And
are you talking? Sorry for interrupting you. So are you talking about just a regular scheduler cache that caches nodes?
The regular scheduler cache. Okay. When we're working on the equivalent cache with Huawei people, actually we don't have enough scheduler cache for not only node side but also the pods or something in the current scheduler cache. So that's why we work out equivalent cache. It is like a helper for the scheduler cache actually. But today we have put enough information in scheduler cache and as well as the metadata.
Yeah.
So I think the benefits of equivalent cache is limited today. That's my opinion. That's what I feel when trying to improve the equivalent cache feature. So I think it makes sense if we revise this kind of effort to see if we want to push forward or we want to replace it with something else. It makes sense to me.
I see. Thank you for sharing your opinion. Yes, you're right. So one thing that actually you mentioned and came to my head is that we do some sort of some amount of pre-processing for all the pods, and this pre-processing happens whether we use equivalence cache or not. So there is basically this sort of fixed amount of overhead that we do for pre-processing and generating metadata per pod, and that's not going to go away with equivalence cache. So all of these being in place, equivalence cache becomes less important. Another important observation is that we have had a few other optimizations recently, especially in basically 1.12. One was the change that I sent to score fewer nodes. That plus eliminating sorting towards the end of scheduling when we select node, the final node among the top scorer, the nodes with higher scores. These all have contributed to performance improvement, and we are seeing 35% better overall throughput of the scheduler. So in some of the CubeMark results that we have for 5,000 nodes, we see about 80 pods per second can be scheduled by the scheduler in large clusters, which is actually a pretty good number. It's not low at all. And for anything around like 2,000, 2,500-ish clusters, or maybe today it's actually even more than that, we are limited by the QPS of the API server. So basically, the scheduler is fast enough to exhaust all the bandwidth that it has from the API server. So all of these are being considered, plus the fact that equivalence cache has very subtle changes and has made some very subtle changes, and it's kind of it's complex. Basically, it needs to be, everybody who works on it needs to be very well aware of all the details about invalidations and when invalidations happen. Every time that we make a new change to the cluster or to the scheduler, we need to think carefully about whether it requires invalidating equivalence cache or not. So all of these combined, I also feel like we may not need equivalence cache, or not that we don't need it, but it makes less sense these days to have an equivalence cache. Is there anybody else who has a different opinion, or do people generally agree with me, or don't? I would like to hear.
Yeah, I think I agree. Overall, I agree with you that equivalent cache maybe not give enough input for the performance. In our products, we also do have similar things, but this will be in the but we involve in such kind of feature case by case. For example, we can do the performance improvement. For example, such as the feature you submit in 1.12, and some enhancement for the affinity about the optimization. Yes, I think for the scheduler performance, we need such kind of feature or such kind of improvement. And when we found that we need a general cache, for example, such as equal cache, we can involve this later. And for the equivalent cache, I think we use append some comments that we would like to isolate equivalent cache instead of invalidate with, for example, some state change, we need to invalidate the cache, and there are several code across the scheduler code. That's make me hard to maintain this part. Yes. I think overall, I think we can revisit equivalent cache, whether this is give enough improvement compared to its.
Yeah, that's a good point. That's a good point. Jonathan was also kind of saying somewhat similar to what you just said. He was also proposing that maybe we can keep equivalence cache for only very few predicates, like, for example, affinity and anti-affinity. One of the issues with this approach is that we still need to keep pretty much all the logic on all the complexity of equivalence cache for even if we want to keep it for one of the predicates, right? So all the invalidation and all the kernel logic with respect to fine-grained locking and everything has to stay.
Yeah. Yes. I think I also would like to isolate such kind of code in just one place. Yes, I know when pod update, when node update, when several things change, we need to invalidate equivalent cache. That's make us hard to maintain our code, and especially for the new contributor.
Yeah.
Yes. I think we we need to revisit equal cache for this part.
Right. And another idea that we could explore, it's kind of similar to equivalence cache, but it's much, in a way, it's much less effective. And it's to basically, when we evaluate a pod, there could be many more pods in a cluster with the same kind of spec, right? So especially when you create a large deployment or you create a large replica set, stateful set, and so on. So they have very similar spec. One idea is that we put all of those in sort of like one group, and then if we actually try scheduling one of them. If one cannot be scheduled, then none of the other pods in that group can be scheduled. So basically, we put pending pods in that group, and that's basically our equivalence group now. And for one of them, and if one is not schedulable, we no longer schedule the rest or attempt to schedule the rest. That gives us some performance improvement, especially in clusters that are always under resource pressure or run clusters committed, because they all have a lot of pending pods. This is especially important in clusters that run batch jobs. This might be interesting to you, Klaus. So clusters that have like large batch jobs, usually there are a lot of batch jobs waiting, and we probably don't want to keep redoing this for every single one of them. So it might be useful to change the scheduler cache to change equivalence cache to something like what I just said.
Yes, I agree with that. Yeah.
Okay, so I don't know if Harry is still interested in continuing this work, but that's one idea for you, Harry, to explore.
Yeah, it's really sound good to me. That is actually one of the original benefits you want to use the equivalent cache to do, and it's live is what we want to do in the scheduler. And another thing I need to mention is, I think we need to focus on to make the current scheduler have a smaller feature set, because we are trying to working out the scheduler framework. We are trying to refactoring the code base. So I think your point really makes sense, because we will ship a minimal feature instead of a huge big feature like equivalent cache. Yeah, it really makes sense. I will working on this effort definitely.
Okay, sounds good. Thank you. So in the interest of time, let's move on to our other items. We have quite a few since Wei is here. Wei, so I understand that tainting node by condition is kind of promoted to beta. So there are still remaining items. Ravi had sent a PR. What is the status of that?
Oh, you mean schedule daemon set, not taint by condition, right?
Oh, sorry. Yeah, sorry. I guess tainting node by condition. Okay, so let's talk about tainting node by condition. So that is there, right? So tainting node by condition.
That is absolutely already promoted to beta, either in code and in the document.
So daemon set, right? The scheduling daemon set is like kind of there, but it's not quite there. There is one PR left to be done. So what is there?
The flag hasn't been enabled yet. So Ravi has a PR still pursuing Janet for the final approval. I think there has been several rounds of reviews, that kind of thing.
So thanks. Since Ravi is here, I can ask him directly as well. So Ravi, do you think we can still merge that PR, given that we are after code freeze now?
Yeah, we should be able to make it. Like most of the PR changes that Janet has asked for, all of them are like mostly comments related, or like they are minor things.
Okay.
Not specific to code changes as such.
Oh, sounds good. Thanks. So gang. Okay, go ahead.
And the other blocker for schedule daemon set was the one that Klaus is working on, right? So I think there is also several rounds of reviews, and also needs Janet final approval. But I think it's really close to the final merge, right?
Right. That one I'm not too worried about, because that's a bug fix, right? So of course we don't have unlimited time for it, but we can still merge it. Despite the fact that we're after code freeze.
Yes, I think this we go through the overall OR review of this PR, and Janet just gave some minimal changes such as code clear up and to add some case for that one. Yes, I think this is minor and controllable. Yeah.
Okay, thanks. And then we had the image locality priority function. That one is also has gone through, and it's going to be enabled by default. Harry, correct me if I'm wrong.
Yeah, the image locality feature is right now on track for 1.12, and of course we decide not to ship the end-to-end test because the test image is too huge, so
right.
the test people is very worried about that. So we ship a very well-designed integration test with it, and I think right now everything works. So let's see how it works in the future.
Okay, sounds good. So these were all the items which we were targeting, particularly for 112. The features. Well, actually, there was this also optimization that I was working on, and it was measured a little while ago to score fewer nodes. That is also in 112. There are several items which are like our longer term projects. Hopefully, we are going to have some early versions of them in 113. One is gang scheduling. Klaus, you can give us an update about the status of gang scheduling. Okay. I'm trying to turn these lights on, and I need to.
Okay. For the gang scheduling, I update another round. I think there is another round design doc review, and we are going to only keep the scheduling part in this proposal right now. And I'm going to separate the life cycle management in the other proposal.
Yeah.
And yes, and there we also have a discussion about the transaction in the admission controller. We are going to introduce resource. This is kind of how many opposed group going to require the resource, and this will we work together with the resource counter. And I just gave a section to describe this speech, this part, and I will give another detailed design document to how to implement this feature. Yes, we need to work together with the resource counter for this part. But yes, in Kubernetes we already have such kind of we already have gang scheduling or call scheduling in the in here without the admission transaction part. Yes, if someone interested, they can have a try for this part.
No, that sounds good. Yeah. So, but I guess you need to given that we are getting closer to finalizing the API, you may want to change the implementation to support the new CRD and all of that, and then for maybe 113 we can have the new implementation of CRD, basically our new API for Cube Arbitrator. So, by the way, do you want to change the name of Cube Arbitrator to anything else, or you want to keep the name?
Yes, I think that's I'd like to change this to such kind of a Kube batch.
Okay.
Or maybe some other. I'm not sure if anyone have other better name for this one, because I think Kube Arbitrator is a batch scheduler. I think such kind of a cool batch, maybe.
Yeah, or I don't know if you want to call this schedule this whole feature co-scheduling. You may want to call it co-scheduler. I don't know. Just throwing ideas.
I think you set up a vote, so people can vote for your names.
Yeah.
Yeah. Okay. Sure. Yeah.
That's my idea.
Very democratic about it.
Sure. Yeah. Sure.
General elections about the name and everything.
Yeah. Sure. I will start a thread for this part. Yeah.
Naming is the hardest thing.
Yes.
Both in coding as well as project.
Okay.
So there were, I guess, at least two big items. One was the scheduling framework. So the scheduling framework, we feel like we have reached to consensus pretty much. At least the PR has been quite stable, meaning that there has not been so many comments about making many changes recently. And I have been in touch with the SIG storage, particularly because those guys needed to have something like a framework to build dynamic volume binding. And Michelle has helped us review the scheduling framework design, and we are thinking about building some of these extension points and plug in like a skeleton of plugin for these extension points for 113. So probably we're going to have some issues filed soon, and some of these smaller pieces of the scheduling framework are going to get implemented into our current scheduler. That's one thing for 113. The other big sort of like longer term project which we have been working on was pod scheduling policies that we have been working with this SIG policy, and Yasin and the company has been working on the PR for the proposal. Basically, we think that we've reached to conclusion on that as well. So we are just trying to work out some minor details about like how the rules should be matched and stuff like that. But otherwise, I guess that PR is that proposal is kind of ready as well, and hopefully we can have some early version of the scheduling policies in place for 113. Given that we have limited or kind of like freeze on standard APIs for Kubernetes, the scheduling policies should also be built as a CRD at the moment. And maybe one day we can promote those to standard APIs. But for scheduling policies, I guess a CRD is not a problem, because the scheduling policies are going to probably be enforced by an admission controller anyway, and the admission controller can be like an add-on that is added, or like a CRD controller that is added to Kubernetes. So we are set for that. Ahmed is here. He is the person that who helped us build the optimization for affinity and anti-affinity. I would like to thank him in person since he's here. Thank you so much for your contributions. Those made a huge difference in the performance of the feature. We definitely needed those performance improvements as the feature was really slow. As some of you folks might know, affinity and anti-affinity, we're talking about pod affinity and anti-affinity. The feature was about 1,000 times slower than many other predicates in the scheduler. So with a couple of optimizations that we implemented for the feature, we saw about 120x performance improvement. So something that in benchmarks, we were seeing that a pod could take like 600 milliseconds to be scheduled when it had affinity and anti-affinity in a large cluster. We are now seeing it being scheduled in 5 milliseconds. So there's a huge performance improvement. I'm really excited about that. Wei is working on another PR to address an issue and the implementation. Sorry that I wasn't able to review it more quickly. Wei, there is like this perf cycle at Google right now going on, and we had to all write our self-assessment and all, and it was colliding with the code freeze as well. So sorry about the delay, but I will definitely review that, and we have to merge it in 112 as well. These are pretty much all the items. Ravi is gonna help us to, basically we're gonna discuss our plans for Descheduler. Descheduler is basically the component that is gonna be built as a separate component for now at least, and helps clusters to have more balanced resources, or well, the details of the features that we would like Descheduler to support is not very clear at the moment, but we are going to work with Ravi and the folks over at HAT to figure those out soon. So Descheduler is also another big item for 113 that we are going to work on. Ravi, if you have further updates, please share them with us.
Yeah, sure. Sometime mid of next week or end of next week, I'll send out an invite. The main topics of discussion would be the features that we have in mind, which are already part of the roadmap on the GitHub page, and prioritization of them, like which ones are important in both short and long term.
Sounds good. All right. Yeah, sure. Sounds great. These are all the items that I wanted to talk about today. As I said, we are going to have some discussions about the features that we would like to add in 1.13. If you have ideas, please share them with us. Or we have this screen. We have this spreadsheet that is available in our meeting notes. The link is available in our meeting notes that we use for planning. Please feel free to go ahead and add your feature requests, or if you are willing to work on any of these features, please go ahead and comment on that or send an email to me directly. We are going to consider those for 1.13. I have a few items as we discussed today, and also some other stuff that I have in mind. I'm going to update the spreadsheet to target the next release. Is there any questions or comments? Oh, going once.
Okay.
Twice. Klaus, do you want to say something?
No,
Okay.
I'm fine. Yeah.
Okay. All right. Thank you, folks. See some of you folks next week.
Okay. See you later.
Bye.
Yeah, same.
Bye.